The missing square puzzle is an optical illusion used in mathematics classes to help students reason about geometrical figures, or rather to teach them to not reason using figures, but only using the textual description thereof and the axioms of geometry. It depicts two arrangements made of similar shapes in slightly different configurations. Each apparently forms a 13A, 5 right-angled triangle, but one has a 1A, 1 hole in it. Solution. The key to the puzzle is the fact that neither of the 13A, 5 triangles is truly a triangle, because what appears to be the hypotenuse is bent. In other words, the hypotenuse does not maintain a consistent slope, even though it may appear that way to the human eye. A true 13A, 5 triangle cannot be created from the given component parts. The four figures total 32 units of area. The apparent triangles formed from the figures are 13 units wide and 5 units tall, so it appears that the area should be units. However, the blue triangle has a ratio of 5 to 2, while the red triangle has the ratio 8 to 3, so the apparent combined hypotenuse in each figure is actually bent. So with the bent hypotenuse, the first figure actually occupies a combined 32 units, while the second figure occupies 33, including the missing square. The amount of bending is approximately January 28th of a unit, which is difficult to see on the diagram of this puzzle. Note the grid point where the red and blue triangles in the lower image meet, and compare it to the same point on the other figure. The edge is slightly under the mark in the upper image, but goes through it in the lower. Overlaying the hypotenuses from both figures results in a very thin parallelogram with an area of exactly 1 grid square the same area missing from the second figure. Principle. According to Martin Gardner, this particular puzzle was invented by a New York City amateur magician, Paul Curry, in 1953. However, the principle of a dissection paradox has been known since the start of the 16th century. The integer dimensions of the parts of the puzzle are successive Fibonacci numbers. Many other geometric dissection puzzles are based on a few simple properties of the Fibonacci sequence. Similar puzzles. Sam Lloyd's paradoxical dissection. In the larger rearrangement, the gaps between the figures have a combined unit square more area than their square gaps counterparts, creating an illusion that the figures there take up more space than those in the square figure. In the smaller rearrangement, each quadrilateral needs to overlap the triangle by an area of half a unit for its top-bottom edge to align with the grid line. Mitsunobu Matsuyama's paradox uses 4 congruent quadrilaterals and a small square, which form a larger square. When the quadrilaterals are rotated about their centers, they fill the space of the small square, although the total area of the figure seems unchanged. The apparent paradox is explained by the fact that the side of the new large square is a little smaller than the original one. If A is the side of the large square and I is the angle between two opposing sides in each quadrilateral, then the quotient between the two areas is given by sec2ia1. For I equals 5 a degree, this is approximately 1.00765, which corresponds to a difference of about 0.8%. References. External links, a printable missing square variant with a video demonstration. Curry's paradox, how is it possible? At Cut the Knot, Triangles and Paradoxes at Archimedes-lab.org, The Triangle Problem or What's Wrong with the Obvious Truth, Jigsaw Paradox, The 11 Holes Puzzle, Very Nice Animated Excel Workbook of the Missing Square Puzzle, a video explaining Curry's paradox and area by James Tanton.